Hello, welcome to my video. This video will be about acceleration data collection with MATLAB programming. My name is Jinawat Magpisai. I'm a student from AIoT major from TAIST AioT program. And this video is a part of my software design course. So let's get started. This demonstration will be based on the literature called Gender Detection with Smartphone Motion Sensors using Convolutional Neural Networks from June 2021, which original title were in Turkish. Actually, the whole paper was in Turkish, and I managed to translate it using Google Docs website. And these two motivational researchers are the authors of this paperwork, and I'm not sure how to pronounce their name, but thank you for this useful research. Okay, if you are interested, you can follow this QR code, which will take you to researchgate.net to download the paper to read yourself. Now, first, let's get started with the research idea. Now, the concept of this research is that they said that user touching the screen or walking behavior are different. So they try to distinguish the gender of the user from the device sensor data. So the procedure is they develop an Android application and collect the data from the mobile phone sensor from 120 users. So 60 males and 60 females with a wide range of age. And these users has to interact with their phone while they are walking. After that, the collected data will be extracted to find the features of this data will be extracted. The feature of these data will be extracted, and then they will find the correlation between data using machine learning algorithms. Now, the conclusion is that the accelerometer gives a better detection result for both genders, and the convolutional neural network has 88.3% success rate, which outperforms other machine learning methods. Now let's take a look at how they use their smartphone. So for the data collection, they collect all three axes, which is x, y, and z of the acceleration data. So how the user interact with the phone is freestyle. So the user are free to hold their phone, free to walk, free to touch the phone in their normal life. The phone used for this experiment is Samsung and LG smartphones to install the application they developed, and the data is collected in 100 hertz sampling frequency. So the figure on the right side of the slide is an example of acceleration values in XYZ while the user is walking. So this is the data collected. And they also process the data to get another variable called ACC sum, which is they said that they do this to analyze the force exerted on the phone, and this is the equation of that force, and this is the equation. And then they try to extract the feature by dividing the raw data, which I believe it's in vector, into time windows. Now, two of these we can do in the MATLAB with no problem. But if you actually classification for MATLAB is available as well. But I think for classification with 5 different methods, which they use scikit-learn model, and they also use the grid search CV to reduce the number of features. Now, it is better for us to extract the data we collected into a CSV file. so that the other programs can use it for implementation furthermore. Okay. Now let's take a look at the live script and the demonstration. First, let me open my MATLAB application on my mobile phone. So it's connecting to the cloud of MATLAB to try to communicate with the user I'm using here and the user I signed in on my phone. So what you want to do is you want to go to this page, sensor. Okay, let's take a look at my screen here. So the first line will list all of my devices connected to my account, and the second line is to connect to a phone of this name. So let's try to run the section. It will try to list every devices, so you can choose between the device name to clarify the device that you want to use. As you can see here, I have only one device. This is the name, and I use this name and connects to my workspace. So as you can see here, the variables are already there. Next, we want to enable the sensor. In this case, we want to use the acceleration sensor. So we run it. 1 is for turn on, 0 is for turn off. Okay, after that, let's see the data collection section. So this first part is the audio notification setup in case so that the user can know when to stop and when to start. So this is basically a system speech and assign it to some variable, and we set the volume to 100. Then we want to set the sample rate. So this is a what you call a control of MATLAB, which you can actually give in the value. So this is my, if you take a look at my phone over here, so my phone can do a 0.5 Hertz to 100 Hertz of data sampling. So I have 0.5 here as a minimum and 100 as a maximum, and we go by 0.5 step each time we slide, and our default value is on 100. Okay, so we can do it like this, and now the mobile phone sample rate will be 46 if we run this cell. So we want to set it to 100. Okay, then we start collecting data. So first we have to discard the logs of the previous experiment, so it's not get mixed. Now this one is the how we use this object to speak, this obj variable to speak. So, and this is the text that it's gonna read. Get ready, and it will pause for 5 seconds to for the user to get in position. And this is the timestamp for our experiment. Then this is the logging. This is where the data collection begins. Okay, so it tells the user to start, let's say about 20 seconds, and then the logging will stop right there. Turn off, turn on here, turn off here, and then it said stop. So the user stop, and they assign the variable, assign the data to a variable. So the first variable will be the acceleration data for XYZ. So this will be a matrix of let's say 3 columns, and how many rows you can tell by the sampling rate. So the sampling rate is 100. That means a number of rows is about so in 1 second we will have about 100 data. So you do the math. Okay, now this is the time. Okay, like 0 to 20. Okay, like 0, 0.5, 0.8 to 20, depending on your frequency sampling rate. Okay, so let's try to do this experiment. Okay, I'm gonna run this cell and let's try to well, I'm not gonna walk, okay? So let's do it in front of this camera.
Get ready.
You will hear something. It already said that. Now
Start.
try to interact with the phone. The good thing about this one is you can actually collect the data, have it collect the data in background. That means you can quit this app and try to do something something else. So the
Stop.
data collection is more natural because the user plays with their phone, right? Now it's finished, and on the right here is the data. So we have A, X, Y, Z, 1, 2, 3, column 1, 2, 3, and we have time here. Then we want to try and process the data. So first we have to remove the gravity. So first here we have the gravity declare as a matrix of size A, but everything in there is 0. Okay, so we have the alpha here for the calculation and gravity as 0 to calculate line by row by row of A. Okay, so we have a for loop here to loop in a length of A, which is each row of A. Then we calculate new gravity every time. So we have the alpha here multiplied with gravity and plus the 1 minus alpha, and each row I with 3 columns. This column means all column, okay? Then we want to update our A no gravity matrix, all columns of row I. Okay, so it will be row I of the old data with no with gravity applied. Okay, so we minus the gravity out of it, right? And we end the loop. Next, we will try to visualize the graph of the old one and of the new one with no gravity. Okay, so let's try to run this cell. In the meanwhile, I try to add this variable ACC sum, which is according to the equation that they give it to us. Okay, so power and more plus everything together. Column X, column Y, and column Z of all rows. Okay, all rows. Now let's compare the plot right here. So this one is a plot that we see in the slide. I try to recreate that. So let's take a look at the right side here. So first we have this acceleration data with the gravity. Okay, so the Z and Y axis are up there due to the gravity, and X is near 0. Depending on the phone you're holding, this value can be differs, but there would be something about here. Okay, always, because there is a gravity effect. So once we take it out, you can see that everything starts near 0 right there. Okay, no gravity. And this is the separate plot for each axis. Okay, X, Y, Z, and ACC sum. Now we have all the data we need. What we want here is that we want to create a data file. So the file name here can be edited using this control field. It's called a edit field control. So this one you can set the default value as well as a label. Okay, so let's name it data, right? And it will concatenate with an underscore, a date, and .csv. So this will concatenate everything. It's you can just use only this bracket. square bracket. So we have t as a first column, and we have x, y, z with no gravity. Then we have another variable acc sum. So we make this array into a table, and we say that we want to add the names to this table, the column names. So we have time, x, y, z, and acc sum. Then we write the file. So let's try to run this. It will save the file right where this this live script is in. So we have this one file. So we can try to take a look. So it's a CSV column, just like this right side over here. You see it's a t. This is variable t with with all column names accordingly. Okay. Now after you finish with your experiment, you want to clear everything. Let's say set it to 0 because it opens with 0. So we want to have it turn off as well. But every time it turns on, the application turns on, it will set the sample rate to 1 to 10 hertz anyway, and our sensors are disabled. So you have to enable it every time. And we also want to clear the workspace for the next experiment. Let's say if we did not clear this workspace and we try to run this the line number 2 here, it will say that it has a conflict of assigning the same mobile to this variable. Okay, it will cause an error. Actually, I can show you here. Let's try. So you can run the section by using Control and Enter. Okay. Also. So let's try. You see, the connection is already exists. So we need to clear everything. Okay, so we run it. And that's about the demonstration. Everything's gone. Okay, so let's get back to the slides. Let's take a look at the advantages and disadvantages for the research of my work. So by using MATLAB, we had an easy data collection, okay, in such a way that we don't have to develop a new mobile application to collect those data. And it also can perform some machine learning techniques, as I say, sklearn, the scikit-learn thing. But for the disadvantages, that MATLAB license is needed. Well, but it has a 30-day free trial, so you can try for 30 days, and if you happy with it, you can ask for your university to fund it, okay, or your company, right? But this one, if you want more sensor that MATLAB did not implement such, if you want to go deeper, MATLAB is not didn't have that function for you, so you may have to develop a mobile application instead if you want to go deeper to your mobile. Okay, and it has a connecting to a mobile device can take some time. Okay, but it's not that hard. But as I show you, it has some errors if you didn't careful, right? And also the last one is that the device rotation, that is MATLAB application, can rotate. So if you rotate the phone, the MATLAB will rotate also. So you might have to check if your phone is enabled for rotation or not. So you have to disable the rotation first if you want to test, because it can calibrate a new XYZ axis every time the device rotates. So, and that's it for my demonstration. I hope this video will be useful, and I'll see you next time. Thank you.